Alright, so this video is going to be part 11 of our sequences and series review. Okay, this video we'll be talking about differentiation and integration of power series. Now, basically, this all starts with this theorem right here. If the power series, the sum of c sub n times x minus a to the nth power has a radius of convergence that is r greater than 0. Okay, so just a radius of convergence greater than 0. Then the function f, which is right here, is differentiable and therefore continuous on the interval of convergence. Okay, now that's big. That means that we can take derivatives and integrals of power series. Okay, so here's just our general power series formula, and let's take a derivative. Okay, if we take a derivative, we get c sub 1, right? And we've done this before, so this should seem familiar to you. Okay, this is a constant, so this goes away. We have c sub 1 as our first term. Okay, next is 2, c sub 2 times x minus a. This will now be to the first power. Next we'll get plus 3, c sub 3 times x minus a to the second power. And that's going to go on and on and on. Now, this will equal the sum. We'll worry about our index in just a second here. Okay, obviously the top point's going to be infinity. This is going to be of, well, remember, we're taking a derivative with respect to x. Okay, that's the idea. We're taking a derivative with respect to x. Okay, this is f prime of x. We're not dealing with derivatives of n. That's a different thing. Okay, so if we take a derivative with respect to x here, this n comes down. We get an n minus 1 up here. So we have n, c sub n, times x minus a to the n minus 1. Now what you'll notice here is that this n equals 0 term, it's no longer existent in our derivative. Okay, so we're going to raise our index by 1. Okay, it's going to start from the n equals 1 term. Okay, that's where the series starts. It's not going to start from the n equals 0 term. That's 0 now. That doesn't matter anymore. Okay, so that's why we start from the next term up for when we take a derivative. Now if we take an integral, let's take an integral of f of x. Well, what we get now is, well, we just have a c, right? We're going to have a c plus c sub 0 times x minus a plus a c sub 1 times x minus a squared over 2 plus c sub 2 times x minus a cubed over 3, and that's going to go on and on. Okay, so exactly what you would expect it to be. Now what this looks like in our summation is just going to be c, right? We're going to have that constant c, whatever that may be. All right, and that's going to be plus the sum from n equals 0 to infinity, okay, of, well, this will just be now a c sub n times x minus a to the n plus 1 over n plus 1. Okay, that's just taking an integral with respect to x. All right, so there you have it. You see taking a derivative of a power series, taking an integral of a power series, and what you get. Okay, it's not really anything that you wouldn't expect it to be. The only thing that I could ever see throwing you off would be that index change for the derivative. Okay, so we're just going to do a couple quick examples, and that'll be it. Now, if we wanted to represent this function as a power series, this function here, x over 1 minus x quantity squared, what we're going to do is we're going to start off with 1 over 1 minus x, okay? So let's start off here, 1 over 1 minus x. Okay, now this, we know that's equal to the sum from n equals 0 to infinity of x to the n. Okay, so what we're going to do now, we're just going to take a derivative of both sides. If we take a derivative of both sides, what you end up with is 1 over 1 minus x quantity squared, right? That's just a derivative of that, and that's going to be equal to, we'll take a derivative of this power series now. Well, that's something we just did, okay? That's the sum from n equals 1 to infinity now of n times x to the n minus 1. Okay, so now you have that, great, but we have an x over 1 minus x quantity squared there, not just a 1 over 1 minus x quantity squared. So what we do is you just multiply x on both sides, and that will suffice, because now we have a x over 1 minus x quantity squared, and that's equal to, well, this x can just go right inside the sigma, okay? It's not dependent on n, let's just put it right in. And if you multiply this x by this x to the n minus 1, you're just going to have an x to the n, right? Because this is x to the first power. That'll cancel out with that negative 1 right there. So we get the sum from n equals 1 to infinity of n x to the n. And right there, that's your power series. Now, another thing to note, when you're taking derivatives and integrals, the radius of convergence is not going to change. Now, we know that the radius of convergence for this geometric power series here, that's 1, right? It's just r equals 1. Okay. Now, if you had something else, okay, if you had something else like a 2x or a 3x inside the common ratio, maybe that radius is going to change. Okay, but here we just have x to the n, and that means that we have a radius of convergence of 1. When we take a derivative, doesn't matter. The radius of convergence will still be 1. Okay, so that's something to definitely know. Okay, so if it asks for the radius of convergence, well, you know that it's going to be the same radius as what you originally had before you took a derivative. Okay, and if you need to find the interval, well, then here we can just use a ratio test or something like that. All right. Now, what if we wanted to find a power series representation for natural log of 1 plus x? Well, here we can start off with 1 over 1 plus x, okay? If we start off with a 1 over 1 plus x, we know that the integral of this is natural log of 1 plus x, okay? So that's going to help us. Now, this is equal to the power series, the sum from n equals 0 to infinity of, well, this is a negative x to the n. Why is it a negative x to the n? Well, remember, we want a 1 over 1 minus something, and we can rewrite this as 1 over 1 minus a negative x. Okay, that something is negative x. That's what goes in to be your common ratio in the geometric power series. Okay, so now what can you do here? Well, remember, I said that you have to integrate. Okay, you have to integrate to get this natural log of 1 plus x. So let's take an integral of both sides. When you take an integral of both sides, you get, like we said, the natural log of 1 plus x on this side. On the other side, you, of course, remember your plus c. Okay, you got to remember that plus c. And, well, now we have the sum from n equals 0 to infinity of, well, this negative x to the n, that's kind of going to be a little bit of a pain. It might be a little less of a pain if you rewrote it as negative 1 to the n times x to the n, because now it's a little bit easier to take the integral. Okay, I mean, you don't have to worry about this negative anymore. It's going to be just that negative 1 to the n staying there, and you have an x to the n plus 1, and that's going to be over n plus 1. All right, and there you go. Now we need to find what our c is, and we can do that easily by plugging in 0 for x. Okay, we're just plugging in a number for x, and then we can test what that c is. All right, if we plug in c for a 0 for x, that's going to affect this side and this side. All right, this side will just become natural log of 1, which is 0. Okay, so natural log of 1 will be equal to c plus the sum from n equals 0 to infinity of negative 1 to the n times 0 to the n plus 1 over n plus 1. So finally you get that 0 equals c. All right, and that means that natural log of 1 plus x could just be represented as the sum from n equals 0 to infinity of negative 1 to the n times x to the n plus 1 over n plus 1. So that's about it. I mean, this is not the hardest stuff in the world, really. I mean, you're just taking derivatives and integrals. The only, there's a couple places that I could see you getting tripped up here. I mentioned before with that index change when you're taking a derivative, but I showed you the whole concept behind why that happens, okay? So the other place that I definitely could see you getting tripped up with, that I've seen other people get tripped up with, is that they don't realize that this is a derivative or an integral with respect to x. They try to take a derivative with respect to n, and that's not how any of this works. Okay, so that ends up being a huge problem for them. So make sure that you realize that you're taking a derivative with respect to x or an integral with respect to x. Okay, so yeah, that's gonna do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences in series and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.